still doing 2.7 graphing techniques, and we're going to talk about symmetry. Now remember, symmetry is like if I have a reflection in the mirror, or if I reflect over a line exactly the same thing. This and this are the same, this and this are the same, so this has symmetry. This does not have symmetry, because if I reflect it over that line, it's not the same. Okay? So we have three types of symmetry for this course. We have x-axis symmetry. So here's my x-axis. If I reflect this over the x-axis, it's exactly the same. So we call this x-axis symmetry. So this shape has x-axis symmetry. Now here's my y-axis. Okay. If I reflect this side over here, it's exactly the same. So this has y-axis symmetry. Now y-axis symmetry, you can also say it's an even function. Now even, remember, is 2, 4, 6, 8, 10. Okay, so we can call this an even function here. Okay, that has y, and it has y-axis symmetry. The next one is origin symmetry. So remember, this is my origin in the middle. So what it is it rotates something 180 degrees. So if I take this object and I rotate it half a circle, it's going to be exactly the same over here. So if I take this and I rotate it half a circle, it will be the same. So it's called origin of symmetry. And origin, because this is the origin here. 0, 0 is the origin. Now, origin of symmetry, if I talk about this function here, this line, okay, not line, this curve, it's called an odd function. Odd numbers, 1, 3, 5, 7, odd. Now I remember odd, origin. They both are O's, so if it's an origin of symmetry, it's an odd function. Okay, so three types of symmetry: over the x-axis, over the y-axis, or rotate it 180 degrees. Okay, so we have a couple rules, two rules. If a graph has x-axis symmetry and it has y-axis symmetry, then it has origin of symmetry. So if you test it and check and it has these two, then yes, it has this one. Another way to do it is, if I have two types of symmetry, then I also have the third type. So maybe there's a graph and I test it and I say, oh, it has these two types of symmetry, then by default it has this one. If I test it and I have these two, then I also have this one. So I don't have to test all three. Okay, we'll come back to that. So let's look and say, what types of symmetry does the graph have? X-axis, y-axis, or origin? So if I look at this one first, here is my y-axis. Is it exactly the same on this side from this side? Yep, it's been reflected from this side to this side. So this one has y-axis symmetry. Okay, let's look at this one. If I look at the x-axis, is it the same from here to here? Nope. So if I look at my y-axis, is it exactly the same on this side of the y-axis and this side? Nope. If I wanted it to be the same, I'd have to draw it like this. That would have y-axis symmetry, but this parabola has been moved over, so it doesn't. Can I rotate it? No, I can't rotate it to make it have origin of symmetry. So this one just has none. It doesn't have x-axis symmetry, it doesn't have y-axis symmetry, it doesn't have origin of symmetry. The next one. If I look at my x-axis, is this side exactly the same as this side? Nope. What about this one? If I rotate it, if I reflect it this way, no, because if I looked at this side, if I want it the same, I'd have to do like this, two bumps like this. That would be the same, but it's not. So it doesn't have x or y. Let's check rotating it. So if I rotate this half a circle, is it going to look the same? Yes. So this is origin symmetry. Now let's look at the next one. So if I look at my x-axis, is it exactly the same on both sides? Yes. So this has x-axis symmetry. What about y-axis? No, it's not the same. It would have to be like this little weird shape if I did that. So there's no y-axis symmetry. If I rotate it, I'm not going to get anything that looks the same. So it's only x-axis symmetry. So let's look at x-axis here. Is it the same from here to here? Yes. So it has x-axis symmetry. Let's look at the y. Is it the same from here to here? Yes. So it has y-axis symmetry. Remember the rule? If you have x and y-axis, then you automatically have origin symmetry. These are both symmetry. I was lazy, I didn't write it. So let's check. If I take this and I rotate it 180 degrees, it's exactly the same. So yes, it has all three. Let's look at the x-axis. No, it'd have to look like this to have reflection over the x-axis, or symmetry over the x-axis. Let's look at y. It would have to do this, but it doesn't. If I wanted to rotate it, then it would need to look something like that. So this has none. No axis of symmetry at all. Okay. So let's look at some examples. Let's look at page 8. Okay. Page 8. We're going to do some examples, and we're going to test to see if it has x-axis symmetry or y-axis symmetry or origin of symmetry. So it says test for symmetry across the x-axis, y-axis, and the origin. Okay, so let's do x-axis first. So in order to test to see if it has x-axis symmetry, so if I look on page 5, sorry for moving it so much, page 5. So if I want to test something for x-axis symmetry, it says replace y with negative y, and you should get the original equation. Okay. If I want to test y-axis for y-axis symmetry, I replace x with negative x. And if I want to test something to see if it has an origin of symmetry, I replace both x and y with negative x and negative y. Okay, so what do we have to do? So if we're testing for if there's x-axis symmetry, I look at the other letter. So I do y. I take my y and I replace it with negative y. Okay, so let's write out my equation. And I'm going to replace the y with negative y. And then write everything else the same. Now I have to ask myself, can I make this equation into the original equation? Well, if I make, these are both the same, these are the same, but this is opposite. So it's the wrong sign. If I change everything to the opposite to make this positive, let's change everything to the opposite. Now y is good, but now these ones are not the same. So there's no way that I can make this equation into this. So I'm going to say no, there's no x-axis of symmetry because these are not the same. Okay? So no x-axis of symmetry. So let's do y. Test for y-axis symmetry. So if I'm looking for y-axis symmetry, I replace the x, I do the opposite. Okay, so now I write my equation out. Now I'm going to replace my x with negative x. So wherever there's an x, I'm going to replace it with negative x. Well, negative x squared is really negative x times negative x. Yeah? Just means write two of them. What's negative times a negative? Positive. So really, this is the same as x times x, which is just x squared. And now I check. Is this the same as the original? Y, x squared. Yes, it's the same. So if it ends up being the same, then you can say yes, it has y-axis symmetry. Okay? Because look, y, x squared, negative 2, or subtract 2, same. So now let's test for origin. Blah. Origin of, oh, we don't need of symmetry, just type origin. So origin, we have to do both of them. We have to replace the x with negative x and y with negative y. So we're going to replace both. So let's write our equation out. Now I'm going to replace my y with negative y, and then my x with negative x, like that. So that's negative y. Oh, negative x squared is equal to x squared, right? Because we just did that. So I'm going to write this is equal to just x squared. There. So now I check. Can I make this into this? Well, this is minus. These are opposite. These are the same. And these are the same. So this part is the same. But this is opposite. It's the wrong thing. This should be positive y. So there's no way that I can turn this equation into this equation. So I say not same. So I'd have to say no. There's no origin of symmetry. Okay? Let's look at the next one. All right. So let's look for x-axis of symmetry. So because I'm looking for x-axis of symmetry, I do the opposite. I replace y with negative y. So let's write out the equation. And I'm going to replace the y with negative y. Now can I make this into this? Well, these are the same, but this has changed. So there's nothing I can do to make this equation into this equation. So I'd say not same. So I'd say no. There is no x-axis of symmetry. Let's do y-axis. So for y-axis, I'm going to replace the x with negative x. Because I always do opposite, y, x. Write out the equation. And replace my x's with negative x. There's 3 x's. Whew, that's a lot. Okay, so we know x times x times x is x to the 3. Let's put it a little higher. What's x or negative times a negative? Positive. What's a negative times a negative? Positive. What's a positive times a positive? Positive. So I don't need to write a sign. Now, what's negative times a negative? Positive. So I'm left with positive x. So now I have to say, is this the same as this? Well, here it has a positive y, but on this side, they're all opposite. So if I multiply these by negatives and this by negative, this changes. And everything will be wrong. So not the same. I cannot make it the same. So no. No y-axis of symmetry. So now, let's check origin of symmetry. That means I have to replace both. So I'm going to replace my x's, my x with negative x, and my y negative y. So let's write out the equation. Okay, and I have to replace both. So I'm going to replace my y with negative y, and my x's with negative x. So I have negative y. Well, I already did this, because this and this are the same, right? So there's my final answer for this. So I'm just going to write up my final answer. Okay, oops, that's a plus. This is opposite, opposite, opposite. So what I can do is multiply everything by -1. So I change everything to the opposite. So if this is negative y, let's change it to positive. This becomes -3, negative x. So now, if I compare this with the original, they're the same. So I can say, yes, it has origin symmetry. Okay? Because this is the same as this. Let's do the next one. X-axis symmetry. So we have to replace the y with negative y. So let's write it out. Y equals 2x minus 10. So instead of y, I'm going to write negative y. I can't make this into this, because this is just changed. This is no y-axis. Replace my x with negative x, write it out. So now I'm going to write, I'm going to replace my x with negative x. So these are the same, but this one is different. So I cannot make this into this. I can't do it. So this is no. Okay. Origin. I have to do both. Replace x with negative x and y with negative y. So my y becomes negative y. Oops, I need my 2 in front. 2. Okay, so now I have negative y equals minus 2x minus 10. So this is the same, but these are now different. So I cannot make this into this. No. But what is this? This is just a line. So if I graph this line, it sort of looks like this. That's my line. So if this is my x-axis, if I reflect it over here, there's no symmetry. This is my y-axis. There's no symmetry. If I rotate it, almost the same, but not quite the same. So there's no symmetry usually for lines, unless it's a horizontal line or a vertical line. Okay? So straight lines, no symmetry, unless they're horizontal or vertical. So let's look at the next one. This might have some symmetry, because when I see an x squared, when I see y squared or x squared, it's a parabola. Okay, so there might be some symmetry here. Don't know. So let's test my x-axis. Replace the y with negative y. So x equals, be careful, because I have to put the negative, and then I'm going to put my y inside minus y, like that. So it's minus, negative y squared just means write it twice. So what's negative times a negative? Positive. What's a positive times a negative? Negative. So this is really going to be negative. Y times y is y squared plus 4. Okay, so let's check. X is the same. Y squared is the same. 4 is the same. Everything's the same. So it's the same, so we say yes. Okay, because this is the same. Okay, so now let's test. Let me see, I have number 4. Let's test the y-axis. So we're going to replace x with minus x, because when we do y-axis, we do the opposite. We do x's. So let's write it out. I forgot to write it out last time. So now I'm going to replace the x. So let's do x. Okay, so now this is the same, but this is opposite. So there's no way that I can change this and keep these the same. So this is no. We don't have y-axis. Okay, what about this one? Origin. Okay, I have to replace my x with negative x and y with negative y. So write out the equation. So this becomes minus x. And instead of y, I'm going to put minus y. This is minus x. So here is the same as this. So it was equal, we already solved it, so let's not do it again. This was equal to minus y squared plus 4. So now let's check. Same, 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 different. Look, this is different. So no, there's no origin of symmetry. Only x-axis symmetry. Okay. Let's look at the next one. Alright, so x-axis, so I have to replace the y with minus y. So let's write it out first. So I'm going to put y. Well, what's this? So minus y squared equals minus y times minus y. What's a negative times a negative? Positive. So y times y is y squared. So this is really just y squared. Is that the same? Yes. It's the same, so yes, it has x-axis symmetry. Let's do y-axis. So I replace my x with negative x and write out the equation. Now I'm going to replace my x. What's the same thing? So minus x squared, it's going to be x squared. So that is just going to be x squared. Oh, that's the same. So yes, it has y-axis of symmetry. But remember, there was a rule. Where's my rule? Page 5. On page 5, it says, if a graph has x-axis symmetry and y-axis symmetry, then yes, automatically you know it has origin of symmetry. You don't have to do more work. So another rule is, if you find symmetry, automatically it has the third type. So because I have yes, yes, automatically I know yes, origin of symmetry. And if you draw this, it's a circle. Okay, that's a bad circle. Let's make a nicer. Yeah, it's a circle. Okay, so you can see it has a y reflection. It's the same when you reflect it over the x-axis, and if you rotate it, it's going to be the same because it's a circle. Okay, last one, I think. Let's check. Yep, last one here. Absolute value makes things positive. X-axis symmetry, replace the y with negative y. Okay. Okay, so this is the same, but this is different. So I can't make the y into a negative y and keep these the same. So no, there's no x-axis of symmetry. Let's do y. So replace my x with negative x. So So let's write out the function for the equation. I'm going to replace my x with negative x. Okay. What does the absolute value do? It makes things positive, right? So it doesn't matter what number I put in here, it's always going to put out a positive number. So I can just take that negative right out. Because look, if I put minus 5 in there, the answer is 5. If I put a positive, just wait. If I have a positive 5, it's going to be 5. So it doesn't matter what's inside here, what number goes in, it's always going to spit out a positive number. So if I have, that's the same as that. These two things are the same, because it doesn't matter what you put in, it's always going to put out a positive number. So this, is it the same? Yes. So because it's the same, yes, we know it has a y-axis of symmetry. So we have, if we had yes, yes, then we'd know yes, but this is no, so I have to check origin. Darn. So I have to do both. Replace x with negative x and y with negative y. So let's write up the function. So replace my y with negative y and my x with negative x. Oops, that's not an x. Let's make it look like an x. Okay, I didn't have to write it out again because it's exactly the same. This is the same as this. So I know that I can just say, oh, it's the same as that, because we already talked about it. So now let's look, is it going to be the same? Well, this is the same, this is the same, but this is not the same. So I cannot make this into that. So not same, so no. No, it doesn't have origin of symmetry. Okay?